So we're going to go through some heating curve practice problems now. All right, we should have hopefully understood what a heating curve is. This beautiful situation, right? Going from a solid, melting that solid to a liquid, heating that liquid up, then vaporizing that liquid to a gas and heating that gas up, right? And we know our two main equations to use during a heating curve. If we understand that, we should be able to solve any kind of question that deals with heating curves. Okay, so this one's real basic. All right, so an ice cube that is 20 milliliters is in the freezer at negative 12 degrees Celsius, and it is taken out of the freezer and it's put on the counter and it melts. Okay, we would all know that if you took an ice cube out of the freezer and left it on the counter, that thing would melt. Then you have a nice puddle on your counter. Congrats. Okay, so it melts and gets up to room temperature, okay, which would be, in this case, 25 degrees Celsius. And your job is to find Q. Find how much heat it actually took to heat up that ice cube to melting point, melt that ice cube, and then heat up that lovely puddle of water on your counter up to room temperature. Okay, so the number one mistake that kids will do, that students will make, okay, is they will say, this is easy. And they'll go, Q equals MCAT. And this is bad. Don't do this, okay? I'm trying to show you the number one trap, okay? Number one trap is you just think it's a no-brainer. And you say, the amount of heat required is my mass. 20 mils would be 20 grams of water. Hopefully, we all remember that water's density is 1 gram per mil. If not, just trust me. Okay, so I have 20 grams, and they'll use the number that they remember for water for specific heat, which is 4.18. And they'll say 4.18 joules per gram degree Celsius. Then they'll say the delta T was from negative 12 all the way up to 25, which would be, 37 degrees Celsius. And then they'll get an answer that's super wrong. Bad. Don't do this, okay? This is why it's actually important to understand your heating curves, okay? And this is a trap that none of you are going to fall into, okay? So when you get a question like this, the first thing to do is to draw a heating curve, all right? Let me just cover that up, okay? So draw a heating curve for this problem, specifically for this problem, all right? I have my temp, always in degrees Celsius, over time, okay? And initially, I'm dealing with water, right? I start at, right here, negative 12 degrees Celsius. And it wants me to heat up all the way to 25. So I'm going to get up eventually to 25 degrees Celsius. However, in between negative 12 and 25 degrees Celsius, something happens to water. Okay, at 0 degrees Celsius, water melts. It's very exciting, right? So this is a multi-step problem. Okay, I'm going to go from negative 12, like my ice cube is going from negative 12 up to 0 degrees Celsius. And then I've hit my melting point. And my ice is going to melt. So it plateaus, right? It flatlines. It's a long flat line. Sorry. Okay? And then when I get to this point, everything has melted. And I am now going to raise the temperature of my water up to room temperature. This is a 3-step problem, okay? I have part 1, part 2, part 3. More calculating than we would like sometimes, okay? So during part 1, everything is a solid. During part 2, I'm going from a solid to a liquid. During part 3, everything is just a liquid. Okay? And if you remember from this horrible situation, right, which equations to use for which parts of the graph, Anytime there's an actual change in temperature, I'm going to use Q equals MCAT. And anytime there is a phase change, I'm going to use Q equals mole delta H. Okay, so multi-step problem. Here we go. All right, so for part 1, I have Q equals MCAT. Right, and this is just for ice, only for the solid. So the Q of just heating up the solid ice cube is the mass of my ice, 20 mils, so 20 grams because it's water. Okay, you should be given a table like this, right? So you shouldn't have to memorize the numbers. If you do, if your teacher makes you memorize these numbers, good on you, man. It's not that bad. It's only a few numbers, but hopefully you're given a table, all right? So you get 20 grams, and then you need the specific heat of ice, not of liquid water. You want it of ice, solid water, right there, okay, 2.11. Okay, so specific heat of solid water, 2.11 joules per gram degrees Celsius. And my delta T just of part 1, I'm going from -12 up to 0. So I changed my temperature a positive 12 degrees. I multiply these things together. Grams cancel out. Degrees Celsius cancels out. And I get an answer of 506.4 joules. That's part 1. Then I have part 2, which is going to be fusion, right? Melting. Q equals mole delta H. We have a small problem because it asks for the moles of water. So you actually have to know how to convert between grams and moles, which is not hard. All right, so 20 grams of water, and do a simple conversion. Get rid of grams. I want to get this into mole. Use your molar mass. 1 mole is 18.02 grams. It's like 1.1 moles. I'm just going to check and make sure I didn't lie to you. Yes. Okay. 1.1 moles. All right. So now I have my moles of water. And I can solve. Q equals 1.1 moles times the delta H. This delta H is of fusion, not vaporization, right? I'm not vaporizing. I'm just melting. And again, that should be given to you. Vaporization, nope. Fusion, yay. 6.01 kilojoules per mole. Given value, okay? So times 6.01 kJ per mole. Your moles will cancel out, and you will find that Q for step 2 is equal to 6.67 kilojoules. All right. Last but not least is this part of step 3, right? Heating up the liquid. This is the easiest part because this is the part that we've all done before, okay? So Q equals MCAT for liquid water. Q equals M is your mass. Should still be 20 mils, so it should still be 20 grams. Your specific heat of liquid water, 4.18 joule per gram degrees Celsius. And your delta T just of step 3, I went from 0 degrees up to 25 degrees. So 25 degrees Celsius. Okay, multiply all those three things together. Grams cancel, degrees Celsius cancels, which is nice because then I get an answer in joules. I'm solving for heat. And it's 2,090 joules. Yay. Okay. The problem is I now have joules, kilojoules, and joules. I cannot add all 3 of these things yet because they need to be in the same units. So I just need to know how to convert between joules and kilojoules. Very easy. Hopefully we all know how to do that. But you just move your decimal 1, 2, 3 spaces back. This is 0.5064 kilojoules. This is already in kilojoules, so you're good. Here's my decimal. So I move it 1, 2, 3 spaces to the left. and I would get 2.090 kilojoules. Okay, so to get my actual total answer, of course I have no other color for you, I have to add up all 3 steps. I'll do it right here. Okay, so for part 1, my answer was 0.5064 kilojoules. That's how much energy it took to heat up the ice. For step 2, I'm going to add them together. Okay, how much energy it took, how much heat energy it took to melt the ice cube, which would be 6.67 kilojoules. And then you add that to step 3, which would be 2.090 kilojoules. Very fun to watch me write out numbers, okay? Add all those 3 things together and you get an answer of 9.266 kilojoules. And this is the actual answer, right? Find Q. Find how much heat it would actually take to heat up that ice cube from the below freezing temperature of your freezer, the negative 12 degrees of your freezer, have it melt and have it sit in a puddle right there on your counter at 25 degrees Celsius. Okay, 3-step problem. Make sure you actually draw out your heating curve so that you realize it's a 3-step problem and that you don't screw up and just try and do this in a 1-step problem and get the wrong answer. Okay? Good. All right.